In Exploration 4.2 and Section 4.2 in general, we figure out how it is that we can draw a cause and effect conclusion when that's possible. So in Section 4.1, we learned that just because two variables are associated doesn't mean that one causes the other. Now we're going to figure out when can we draw a cause and effect conclusion. Now, if you haven't read the opening of this exploration, Have a Nice Trip, you should pause the video and read through it for yourself. I'm not going to read it to you, but you can read it and then start the video again, and then we'll see where we're at. So, a couple words that you may not be familiar with: biomechanics, which is bio meaning to do with the body, and mechanics is how your sort of joints and muscles and bones all sort of fit together to help you move around. And gerontology has to do with older people. I don't know if you've ever heard the term geriatrics. A geriatric doctor or geriatric nurse is one that works with older patients. So they're trying these recovery strategies for when people trip, so that hopefully they don't fall and break a hip, which is very common in older people. We have some definitions on the right-hand side there of observational study versus experiment, treatments and control. Make sure that you read through that. And so we're trying to figure out whether the different strategy that we're teaching, one is called lowering and one is called elevating, if one might be better in terms of helping someone recover from a trip. So in question 1, they suggest maybe we could put all the females in the elevating strategy group and all the males in the lowering strategy group. And this is not a good strategy because suppose, for example, that the female group tended to do better at recovering from their trips. Then we wouldn't know, is that because they're females and there's females tend to recover better, or is it because they were all assigned to the elevating strategy and it's the elevating strategy that's better? So it's not a good idea to put all of the same sex in one group, because if one group does better at recovering, we don't know if it's because of the strategy of the group or because of the sex of the group. So number 2 says we could assign 4 females and 8 males to each group and to show how the proportion of males in each group is the same. So group 1 has 4 females and 8 males. So group 1, whoops, that doesn't look like a 1. The proportion of males in group 1 is 8 out of, there are 12 people in the group altogether, 8 males plus 4 females. So 8 out of 12, which is 2/3 or 0.667 or about 66 or 67% males. Now group 2 has 4 females and 8 males. So in other words, we put half of the 8 females in each group and half of the 16 males in each group. So in group 2, the proportion of males is once again 8 males out of 12 people in the group altogether. So we have the same proportion, 0.667 of males in group 2. So number 3 says, now if one of the groups had better recovery, so let's say group 1 is the elevating strategy and group 2 is the lowering strategy, could the reason for the difference, if one group tend to have more people recover from their trip, could that be because of the sex? And the answer there is no, because the groups have the same proportion of each sex. So it's not like one group has a much higher proportion of males or a higher proportion of females. Hopefully you realize that if the proportion of males in each group is the same, then the proportion of females in each group is also the same. So we didn't do that calculation in number 2, but each group is 2/3 male and 1/3 female. So if the two groups, if group 1 tended to perform better, we couldn't say, well, it's because they have more males in that group, because the proportion of males in each group is the same. Now they ask, could this be due to other variables aside from the recovery strategy, we know it can't be due to the sex, and I said, well, maybe, what if height affects your ability to recover? Maybe shorter people tend to recover better just because they're lower to the ground. Does one group tend to have taller people in it? That's something that we'd have to check. So number 4 says, because there will always be more potential confounding variables that might be unevenly distributed between the groups, identify a better method. So in other words, if we thought that height had an effect on recovery strategy, then we could try to make sure when we put the people in the groups that we don't tend to put all the tall people in one group and the short people in the other. We try to have a mix of heights in each group. But that can get really tiresome if you try to think of every possible variable that might affect people's ability to recover. So our method is to randomly assign subjects to strategy groups. And so the different strategies are what we might call the treatments that were in the definition above under experiment, right? Treatments or a control. So those different strategy groups we might call treatment groups. So remember in Chapter 2 we learned about the importance of random sampling and how if you randomly sample from the population, then your sample tends to be representative of the population. This is a different thing. Random assignment, you use, as it says, you use a chance device to make the assignments. So there's a difference between, I'm going to make a little note here, random sampling versus random assignment. They are not the same thing. So now you have to be careful that you can distinguish between one or the other. In other words, you might not have gotten the subjects for this experiment by sampling them at random from the population. This might be a convenience sample, for example. But once you got them in your sample, then the way you assign them to whether they're doing the elevating or the lowering strategy, that assignment could be at random. So, as it says here, the role of random assignment is to balance out potentially confounding variables that gives us the potential to draw cause and effect conclusions. So in section 4.1 we said we cannot assume that because two variables are associated necessarily means that one causes the other. And now we're saying if we want to be able to draw a cause and effect conclusion, then we have to have used random assignment, different than random sampling, to put the subjects into their treatment groups. Now, they do mention here the new terminology of experimental units versus observational units. I just want to warn you, you will have some questions that ask, is this an experiment or an observational study? And you don't want to go by whether they're calling the subjects observational units versus experimental units, because my experience is that observational units is often still used even in an experiment. So you don't want to say, well, they called the subjects observational units, therefore it must be an observational study. Not necessarily. Just be aware of that. Okay, number 5 says, let's see what random assignment looks like. So we're going to put each person, there are 24 people in the study, right? 8 of them are females and 16 of them are males. 24 people altogether. We're going to put everybody's name on a slip of paper. We're going to drop all the slips in a hat and mix them up. Then we're just going to randomly draw out 12 slips. That's going to be one group that goes to the elevating strategy. And it says, what proportion of this group do you expect to be male? So we expect 8 out of 12 to be male because we expect half the males to wind up in each group. So it says, what proportion of the lowering strategy group do you think will be male? Again, 8 out of 12. Then, do you think we will always get an 8-8 split in each group? No. But tendency is for half the males to wind up in each group. Okay, so again, just like when you toss a coin, if you toss the coin 10 times, you don't necessarily get half heads and half tails. If we randomly choose names for each group and we randomly pull out 12 people for one group and 12 people in the other, we don't necessarily get exactly half the men in each group and half the women in each group, but that will be the tendency. So we will tend to get half the males in each group. There will be some variability, but that will be the tendency, is to have half of each sex in each group.